Welcome everybody to another lesson. I hope everybody had a great Christmas. Happy holidays and happy Hanukkah to any of my friends on here that celebrate it. Today we are going to talk about simplifying fractions. What does it mean to simplify a fraction? Well, let's take a fraction here. We have 2/4. So, to simplify a fraction and put it in its simplest form, that means to find any common numbers between the numerator and denominator that we can factor out. So, we have 2/4. Well, this is where factoring comes into play. Factors of 2 are, well, it's going to be 1 and 2. 1 times 2. And then factors of 4 are, well, 2 times 2. And then so both numerator and denominator have factors of 2. So we can cancel out one of the 2's from each, and you're left with 1/2. 2/4 equals 1/2. That's putting it into its simplest form. Well, let's try another one. How about 3/9? Let's do 3/9. Alright. So 3/9. Are there any common factors we can factor out and reduce it to its simplest form? Yeah, we can. Factors of 3 are 1 and 3. What are some factors of 9? What are factors of 9 that have 3 as a factor? Well, 3 times 3. So we could factor out a 3 from each. The 3's will cancel. You are left with 1/3. So 3/9 equals 1/3. And that's it in its simplest form. There's nothing else you could factor. Alright. How about, what if I give you something like 4/10? 4/10. This one's probably not as apparent. So, what are some factors of 4? What are some of 10? The trick is, are there any factors of 4 for 10? There are not. There are factors of 2 for 10, but there's no factors of 4 for 10. So we know there's factors of 2 for 4 and factors of 2 for 10. So we're best to write it in factors of 2. So 4 is 2 times 2. Those are factors. 10, you have 2 times 5. Well, we notice here, numerator and denominator, we can cancel one set of 2's, and you are left with 2/5. And 2/5 we can't reduce any further, so that would be your final answer. Alright, let's see here. What if I gave you 4/40? So, what if I gave you 4/40? Do both have a common 4 that you can factor out? Do both of them have factors of 4? They do, actually. 4, well, you're going to have 4 and 1. Those are factors. And then 40, you'll have 4 and 10. So we can cancel out both 4's from the numerator and denominator. You're left with 1/10. And that does not reduce any further, so 1/10 would be your answer for simplifying it. Alright. How about if I gave you 18/81? Probably not as immediately apparent what it's going to be. There's no factor 18 doesn't factor into 81 at all, so that's not going to cancel out. What other numbers would work? How about 9? We know 9's a factor of both. So 18, you have 9 times 2. 81, factors of 9 for 81, well, it's going to be 9 times 9. And then since you have a common 9 in both the numerator and denominator, that'll cancel out. You're going to be left with 2/9. And that would be your answer. You cannot reduce 2/9 any further. Okay, let's see here. How about 25 out of 100? Okay, 25 out of 100. Do either of those have a common factor of 25? They actually do, because 25, you can do 25 times 1 as a factor. Then we know 25 times 4 equals 100. So you have your factors there. 25s will cancel out. You are left with 1/4. You can't reduce 1/4 any further, so that's your answer. Now, let's say you have two fractions here. You want to see if, for example, we have 3/6, and they're trying to say it's equal to 1/2. But you're not sure if 3/6 is equal to 1/2. There's a way to know that. How you're going to do it is you're going to cross multiply. These are called proportions, which we will get to a little further down the road, but what you're going to do is you're going to cross multiply. So you would take the 3 times 2 and 6 times 1 and set equal to each other. So you'll have 3 times 2, set it equal to 6 times 1. Well, 3 times 2 is 6, 6 times 1 is 6. If you get a true statement, then that is in fact they are in fact equivalent fractions. They are in fact equal. But let's say, does 4/5 equal 8/15? We want to find out, does 4/5 equal 8/15? So again, cross multiply. You'll have 4 times 15, you'll set it equal to 8 times 5. So you'll have 4 times 15, set it equal to 8 times 5. Well, 15 times 4 is 60. Set that equal to what's on the right? 8 times 5, 40. Well, we know 60 does not equal 40, so 4/5 and 8/15 are not equal fractions. How about, let's see, 3/27, does that equal 1/9? Well, again, cross multiply. You'll have 3 and 9, so 3 times 9 is equal to 1 times 27. So 3 times 9 is it equal to 1 times 27. Well, 3 times 9 equals 27, and so does 1 times 27. You got a true statement, so yes, 3/27 does in fact equal 1/9. So if you're ever unsure, cross multiplying is a good way to check. Let's see. Let's reduce one more fraction to simplest form. We're going to have, what about 600 over 1,000? Let's reduce one more fraction. Well, a quick trick when you're working with multiple zeros, when you have multiple zeros in division, this only works with zeros, not other numbers. You can cancel out however many zeros between the numerator and denominator. If you have 2 in the numerator and 2 or more in the denominator, you can cancel that many out. So that already reduces to 6/10. However, it's still not in simplest form yet. We're left with 6/10. Well, unfortunately, 6 doesn't factor into 10, so it's not going to be such a cut and dry one. However, they both have a common 2, don't they? So let's figure out 6/10. They both have a common 2. 2 times 3 is 6, over 2 times 5 is 10. Well, now we have a common 2 in each of the numerator and denominator. We can cancel both of those out. You are left with 3/5, and that would be your final answer. One more. How about 72 over 81? Again, probably not readily as apparent what it's going to be. This is where knowing your times tables and factoring is very important. Are there any common factors of both that'll factor out, of both 72 and 81? Well, 9's a common factor of both, because 9 times 8 equals 72. 9 times 9 equals 81. You can factor out a common 9 from both the numerator and denominator. You are left with 8/9. And that's, you can't reduce 8/9 any further than it already is, so that would be your answer. Again, if you have a theory as to whether, going back to factoring, if you have a theory as to whether a number is a factor of a number, or and you're not sure, you can always use long division to find out. And if you get a remainder of 0, that number is a factor. So just remembering that from the factoring lesson, that'll help you out. But that's all I have for today. Next lesson, we are going to talk about multiplying fractions. Thank you, everybody. Have a good night.